for us? Nice, thank you. Okay, so to start us off, I just wanted to address a couple of the things that people brought up in our post-class survey. Thank you again to everyone who responded to that. It's super useful information. A few of you were a little bit frustrated with the pace. I think that as we actually start getting into some coding here, we'll kind of find ourselves on a little bit more even ground. And I know that a lot of people are anxious to get started coding because we really haven't done a ton of that yet. This week begins the end of the sort of intro part of the course, and now pretty much everything else is going to be coding oriented. So hopefully this will be more kind of akin to what you joined the class for in the first place. We're also still sorting out kind of our timing of breaks and trying to make class as comfortable as possible. So hopefully we will have a more middle of the class time for a break today and give you guys plenty of time to get up and stretch your legs and find something to drink, let the dog out, whatever. Let's see. I think that's about it for that. So let's recap on the homework this week. How did the homework go for folks? Did people run into any problems?
One thing that I saw in the homework was I tried to use an absolute file path initially, so it wasn't like the image wasn't loading. And then Christian gave me some really good tips on how to use a relative file path instead. So originally I was just trying to put in like the file path for my computer, which was like users/Becca/the folder, but then instead I wound up doing just like /images, since that folder is in the GitHub setup as well as on my computer. So then that way it would be visible to others and GitHub, because when I originally just did a file path for my computer, I didn't think through that on GitHub you can't actually see the image because it doesn't know what I'm referring to.
Awesome. Yeah. So Becca and I think a couple other people ran into this problem where GitHub doesn't understand the file paths that are in your computer. It just understands the paths relative to the repository. Did anybody else have problems?
Yeah, I had a similar related problem. I figured out not to use the absolute file path, but then had created the images folder but not pushed things to Git. And so I spent like 2 hours being like, the folder is here, why can't it see it? And then realized that I just needed to like push it, and then I was done.
Nice. What else?
I had a problem where I just looked up the language to add a file to, or add an image to a markdown file, and then tried to run that in an R script and kept getting an error message and was confused about why it wasn't working before it was kindly pointed out to me that that wasn't meant to be run in R and was just meant to be on the markdown file.
So I think that is a really common problem to run into, and it probably stems at least a little bit from us not fully explaining the assignment, which was at least in part an effort to get you folks Googling. But if you figured it out on your own, what you probably discovered was that Markdown is a different language from R, and when you're using RStudio, it is expecting to be told commands in the R language. So if you travel to Italy and start speaking Lithuanian, people are going to give you really weird looks. Just because you're speaking another language does not necessarily mean it's the right language for the environment. So yes, if you are talking to RStudio, it expects you to be talking in R, not in so-called Markdown, which is a different language, but one that GitHub understands for its README files. I think those hit the biggest problems that I heard about. Did anybody else run into issues? Okay, cool.
I did, sorry.
Oh, go ahead.
I did have the same problem, but I didn't solve it. So I give up after a couple hours. So,
Oh no,
yeah.
I'm sorry. All right, well, we're gonna run through it quick here together. So I'm going to share my screen, I think. Yes, I am. And so if that worked properly, can everybody see my RStudio? Looks like yes. Okay. So right now I have my
Wait,
in class.
Christian,
Can't
we
see
can't.
your studio.
I'm
It's
sorry.
your Google Docs screen.
You see my Google Docs screen. Okay. Let's try that. Is that RStudio?
Yes.
Okay, thank you. All right, so we have my in-class repository up here with my README Markdown file. And would somebody like to walk me through the convention for how we tell Markdown that we want to include a picture?
With an exclamation point and alt text in brackets.
Excellent. So I am going to use, rather than a picture of some file paths, I'm going to use a picture of a pretty flower. And then after that, we'll use a parentheses. And some of you also may have run into, I don't think that we mentioned it in the last 2 minutes, but the difference between using quotes and not using quotes. Typically with R, it expects to see file paths and stuff in quotation marks, but with Markdown, it doesn't want to see that. So we will navigate to my images subdirectory, and then I can't use a tab complete because we're in Markdown, and I don't remember what the image is called. It looks like it's img 2788.jpg. So now, ideally, if I push this change to GitHub, it should appear on my README file on my GitHub account. So added path to image for my commit message.
Wait, do you want
And
to pause, Christian, and let anyone tell you about the mistake you might have made?
yes, that would be great.
Did you pull from GitHub before starting today?
I did not pull from GitHub before starting, so thank you for that. Does anybody else see any problems?
Yeah, you need to commit the creation of the images folder, right?
Yes. So I will add the images folder and its contents to this commit. And now, ideally, we'll see if it works, but GitHub should end up with a new folder in my repository that contains an image, and the README will have that image on it. So let's commit and push. Moment of truth. There we go. All right. So let's check out my repository now. And we will see there's now an images subdirectory here with this 22 seconds ago commit on the update to the README and the images directory. And if we scroll down, we will find a pretty flower. So if you had trouble with the homework assignment, you can probably find someone else's repository on GitHub and see how they did it, or hopefully you were able to follow along with this.
I have a quick question about pulling. Do you always pull right before you push it back up?
That's a great question. It's generally best to pull before you do any pushing, especially if you're doing collaborations with other people that are also working on that GitHub repository. Because if you start pushing changes without your computer's Git understanding that other changes were made up on the cloud somewhere, things start to get really confusing really fast. So one thing that a lot of people will run into, especially when they're new to GitHub, is they will manually edit something on their GitHub repository. And then if you don't pull before committing changes that you made on your computer, Git gets very confused about which is the like correct version to be dealing with. Liza, and I see Michael is here too. Do you guys have any further comments on that?
Yeah, and I think Rachel pointed it out in the chat too, that as my rule of thumb, I would pull, like I sit down to start working on code that day, and it's the first thing I do, because if I'm collaborating with someone and they have made an edit to a document I want to start working on, it will make that process a whole lot easier and prevent any conflicting versions depending on if you're on the master or on a different branch.
Yeah, that's a great point.
Yeah.
And I am, oh, go ahead, Michael.
Just gonna say, echo the same thing. Yeah, pull before. It's not like you need to do it before every change that you make, because especially if you're the sole person working on it, you know, you pull down once just in case you forgot that you made a change somewhere else. But then once you continue working, no changes have been made elsewhere because you're working locally on your computer. So then you don't need to do it again. But always just good to pull first thing, because odds are you may have forgotten something.
Yeah, and I would add that a major tenet of this class is trying to teach you all best practices. And in the real world, none of us are practitioners of best practices 100% of the time. I am really bad about using GitHub the right way. You will probably find the right way that's best for you. But I think in general, it's definitely best to pull before you push, and just pull at the beginning of starting up working on something. Cool. Let's see, is there anything else that I need to talk about for the homework before we move on to class? Oh, spaces is another thing. Some people, it sounds like, ran into issues with spaces in using the Markdown language, which is, again, a little bit different from R. So in general, if you're looking up how to use a new language or a new piece of code for an existing language that you already know, follow the formatting conventions they use on whatever website you're using for reference, because in general, if somebody posted a tutorial online, they pretty much know what they're talking about. All right, so I'm going to get out of this R project. I'm using two different R projects that you'll see me bounce between, because Liza and I have a shared project on Dropbox that allows us to push the live code to all of you. So if you see me editing in this R Davis 2020 class scripts, it's a different repository. It's not a big deal, but it's there because you all need to be able to see the live code. So if you all want to open up your RStudio and navigate to the week 3 live code, you should be able to follow along from there.
Hey, Christian.
Yes.
I think also one of the questions that came up in the post-class review was a question of, should I be coding along with you both? And you could speak to that, but I think that, it is a lot to have to see our code and then have your code, and then maybe following the live code on the website, like on one screen. That's absolutely impossible. I think I would, and we can dialogue about this, but I would encourage following along on your own and referring to the live code if, we've scrolled past something or when you later review it. And those would be kind of to me, the two focused bits is like our Zoom screen and your RStudio. And then, I don't know, Christian could weigh in on that, but just as far as a refresher on screen management and sort of what you should be doing during this session.
Yeah, totally. I think your best bet is to try to follow along as closely as you can. And then if you do find yourself getting a little bit behind, then you can just pull up the live code link or like your Google Chrome or whatever internet browser you use really quick and refresh it and copy the code and get kind of right back in action. But definitely Zoom and RStudio are probably the good foci to have. So with that, we're gonna begin the real core coding stuff in class. Today's material is maybe a little bit cursory for experienced R users, but a lot of this stuff is really good to have a keen knowledge of, because you're going to end up running into errors down the line, whether it's today or next week or next year. And having a foundational knowledge of what types of objects you're using in R and what are vectors and things like that will help you understand the errors that you get. And they'll also help you develop sort of a better Googling skill that will allow you to overcome a lot of these things. So something we talked about, I can't remember if it was last week or the week before, was that R is an object-oriented coding language. And so that means that R likes to store things in so-called objects. So we could say X is 5. And if we run this, we can then look at X and see that it is the number 5. But X is not just 5. X is technically a so-called vector that has a length of 1, and the single element of that length 1 vector is the number 5. We can have vectors that have more than one element. For example, we could say the weight of some sort of animal or a series of animals is a we'll say we have 4 animals and there are 4 different weights, and we use this C function to indicate that we have a vector that's a length of more than 1. So we could say, and it stands for concatenation, which is a strangely long word for such a short named function. But we could have a vector that is 10, 29, 14, and 12. And so now we're looking at this vector that is of length 4, and we can verify that by just simply looking at our weight in grams that returns 4 numbers, which are the contents of this concatenation. And these are numbers. But vectors can also be like characters, for example. So we could say a series of animals is comprised of elephant and rat and kangaroo. And now if we look at animals, we'll see that it is a length rat and kangaroo. You'll notice that each of these elements has quotes around them. So let me add some notes here so that people following along in the live code can keep up. So we have vectors that contain characters, and up above we have vectors can contain numbers. Okay, so when you're dealing with character vectors, it's important that the quotations that you use are around each individual element. So if I made a strange animal vector that contained, quote, elephant, comma, rat, comma, kangaroo, and then end quote, does anybody have a guess how many elements exist inside this vector called strange animal? I see at least, I can only see like 4 of you, but I see somebody holding up 1 finger. That's correct. So if we run strange animal, it is a vector that contains this whole thing as 1 element. So we need to remember to separate elements in vectors by commas. Now, I keep talking about how long these vectors are, but can you really tell from looking at this output of strange animal that there's only 1 element in there? I mean, it looks kind of like there's 3 aside from the quotation marks. So we can use another function called length, and input whatever our object of interest is in this function, and it'll tell us how many elements are in it. So let's try length of weight in grams. And sure enough, we see 4 because there's 4 elements in weight in grams. But if we say length of strange animal, there's only 1 because the separation was not, like the use of commas was not outside of the quotes. Let's see. Okay, so another thing, let's add another comment here. How long is my vector? We can also see what types of objects live inside these vectors. So checking vector type using the class function. So if I say class of, let's look back up here. We had the original object that we made was just called X, and it's just the number 5. So if we run class of 5 or of X, we'll see it is a numeric object. If we do class of weight in grams, should this be different or should it be the same? I'm not totally sure. I have a feeling it's going to be the same. We will see. Yes, sure enough, it is the same thing because it's a vector that's composed of just numeric objects. But if we run class of animals, we should see that it is, rather than being a numeric object, it is a character vector. So this will become super important, especially as you start, like if you're doing a linear model that has different levels of predictors, like land cover type or something. You wouldn't want your land cover to be 1, 2, 3, 4, 5, 5.5. It would be shrubs, trees, barren ground, etc. And so differentiating these types of classes can be pretty important. We can also get a closer look at the structure of our objects using the str function, which is short for structure. So if we use structure of weight in grams, oh no, what did I do? I misspelled weight in grams. So thankfully, that was a useful error message. And with a simple adjustment, we can see, okay, so the structure of weight in grams here, we're looking at a numeric object that has indices 1 through 4. So starting with the first index, the value is 10, as we can see up here when we made it. The second is 29, the third is 14, and the fourth is 12. We can also look at the structure of animals, and this should give us a similar output, but rather than num, it should say char or maybe even character, and then 1 through 3 and the contents of that. Okay, it's chur, which is short for a character. Let's see. Okay, so if you have a vector already, but you want to make it a longer vector with additional stuff, you can wrap the concatenation function around the existing object and throw some more stuff in there. So let's make an example. Make a vector longer. If we have weight in grams 2, so this is a new object that we're going to create, we can say it is going to be composed of weight in grams, and we'll add a really heavy something that's 1,500 grams. And now if we look at weight in grams and compare it to weight in grams 2, we'll see that there are the same first 4 elements, but then a new 5th element in this second object. We can also add stuff at the beginning if we want. So weight in grams 3, we'll make this a 0.2 gram thing, and then weight in grams 2. And sure enough, we'll see that weight in grams 3 has a new first element, and then the 5 elements of weight in grams 2 will get tacked onto the end of that. And sure enough, that's what we see, except what got added here? Now we see all these decimal points that didn't exist before. Does anyone have a guess for what happened?
Is it because you used a decimal point in the parentheses, and so then it added parentheses, decimal points?
Yeah, so it's kind of like what you probably learned about with significant digits in chemistry, although this is slightly different. So I probably shouldn't have said that in the first place. Forget what I said about significant digits. When you are dealing with integers, that is whole numbers, R is like, cool, this is just a whole number that doesn't have any decimals or anything. But as soon as you start adding decimals to stuff, R wants to coerce the entire object to sort of match that formatting. And we'll see lots of coercion here in a second. But because that's confusing, I'm going to make this first thing 2. And now we're back to decimal-less numbers.
Brandy has a good question. I don't know if she wants to ask it or if I can just read it out.
Yeah, that'd be great.
But Michael answered it. But yeah, when you have a decimal like that, it changes the form of those numbers from an integer to a double, as Michael said in the chat.
Excellent. So one way that we can look at this whole integer versus float, the non-integer form of numeric objects is called a float, because you can have a floating decimal that moves around. You can explicitly call an object an integer by using an L. I'm not sure where the convention comes from, but let's say this is an integer is 2L. And this will come out to be exactly 2. But if I say this is a float and say 2.0, this is a float, will also read as 2, but these are actually different objects, different types of objects. And I don't think it's class that I would use. Is it type of, Michael? Oh, it's a double, I'm sorry.
Double is just the same thing as a float. It's a type of floating point decimal. Has double precision. It just means you can have a lot of points after the decimal.
Oh, nice. Okay, so we can see there's differences between doubles and integers from a sort of underneath the hood perspective. It will not be super important, at least for today. I can't think of a case where it's going to end up being important later in class. But sometimes if you're looking at documentation for R stuff online, you'll see people have like 1L or 2L in their code. And that's just indicating that that code is expecting an integer rather than some sort of decimal numeric. Oh, so there's one other type of object that we didn't talk about yet, and that is a logical object. You can maybe guess what a logical object is. It's a true or false. So if I say true, R will return true, but if I say type of true, R will tell you it's a logical. So again, a lot of times if you're in the help section, you'll see that under the arguments, it tells you what type of object functions expect for each argument. And so when you're taking the log or exponent of something, R is expecting to receive a numeric object. If you said log of true, let's try it. I don't know what's going to happen. Okay, this is actually a really interesting case where true and false can sometimes be coerced into 0 and 1. Well, in the opposite order, false is often 0 and true is 1. And the log of 1 is probably also 0, right? Yeah, because anything raised to the power of 0 is 1. But if I said log of couch, R would not be happy because it can't convert couch into a number. Okay. So we've talked about type of, and we've talked about class. Did we talk about class? Yes, we did. So from here, we have a little challenge for you, and you can find it on the course materials tab of the website under how R thinks about data. And if you scroll down to, or just click on challenge here, it will bring you to this challenge. And I briefly mentioned coercion, and this challenge is going to reveal a lot of traits that R takes on when it's doing these sort of coercions. So on your own for 3 minutes, just look at this challenge and try to think about what's going to happen. And then once you've thought about it and come up with a guess in your head for what you think will happen, try running the code and see what happens. And then we'll stick you into some breakout rooms and you can discuss in small groups what happens, what problems you ran into, and then we'll reconvene from there. So go ahead and take 2 or 3 minutes and then we'll stick you into some breakout rooms. All right, should we split up into some small groups?
Okay. Is everybody seeing breakout room invitations? Cool. I see.
Nice. What's up, everybody? You're muted, Liza.
Hi.
Did Michael go into a breakout room?
Yeah, he did.
Or you just fled?
So, Christian, sorry, I didn't know if you were intentionally making a mistake at the start, but I interjected anyways.
I was not intentionally making it. Oh, wait, with the GitHub thing?
Yeah,
Yeah, I was.
the images thing.
Christian, what about factors as a type of thing in R?
Yeah, I'm actually not
Part
sure
2
why.
of the lesson.
What?
I said part 2 of the lesson.
Oh, okay, cool.
I talk a bit about them as.
Oh, awesome. Yay. I need a review on that anyway, so.
Factors are the biggest pain.
See, I think I love factors.
What?
As a social scientist, I only deal in factors, almost exclusively. Like,
I was gonna say a lot of the novas and stuff in statistics, like you have to manually convert stuff to factors to run your stuff.
Yeah.
Does it not just coerce stuff at the end of the day on its own?
Not some of those functions.
A lot of the time in models, I just end up putting factor in, like if it's not already coerced, you can just write like factor, and then if it's your like y whatever, it will just, like, the model accepts that, which is nice.
Also, should I be pausing the recording while we're...
Yeah, that's a good thing to remember.
Okay, so it looks like we have everybody back. What did we come up with for this challenge? What happened to num_char?
it turns everything into a character.
Okay. And does that kind of make sense why that would happen?
Yeah.
It seems easier to turn 1 into the keyboard idea of 1 than it does to turn A into a number, doesn't it? What about num_logical?
That one, things become a number, so the true becomes the number 1.
Okay, so that was kind of like what we ran into when I ran log of true, which was a little bit silly to do. And that kind of makes sense if you think about the
I have
zero
a
and
question about that.
Uh-huh.
What would happen though if you, I mean, I haven't done it yet, but what would you do if you had like a list or a concatenate of like 0, 1, 1, 0, 0, like as numbers, and then you have a true or false? Would it still turn it into a number, or would they all turn into true or false? Like, is there a hierarchy
Let's find
of
out.
what turns into what?
Can we turn just zeros and ones into logicals? Let's see. Okay, so let's do a concatenation of 0, 1, 0, 0, 0, 1, 1, 1, true. Looks like it turned the true into a 1. But what if...
So that must be the general rule.
Yeah, it looks like if there are any numbers and just trues and falses beside the numbers, you should end up with just numbers.
What if you do the true first? Does it matter which one comes first on the list?
That's a good question too. Let's try true, false,
That would be, yeah.
1, 1, 0. Looks like it still likes to go back to numbers at the end of the day.
Yeah. So that must be like hierarchically, like you default to numbers if numbers are there, or I guess integers, or are they numbers?
They're, at the end of the day, they're numeric objects. So they could be integers or floats or doubles or whatever R calls it. But
yeah, there's actually a structured progression here where you go from true, false. Logical is actually the most strict, can be only 0 or 1. Then integers, because 0 and 1 are integers. Then double, because you can go from a bunch of integers and then one with a decimal. Now it's double. And then from there down to character, which if everything comes down to characters, and this is the one that will bite you, or this is the one that will happen the most, where something you don't think is characters is a character because someone added a typo and the 300th entry of this column, someone accidentally had a comma in there.
yeah, so if you import a data set from Excel and somebody includes a G at the end of their weight measurement in one entry, that whole column will be a character rather than the numbers that you're expecting it to be. So oftentimes, if you use that structure function to look at a data set and you see that something is a character when you expect it to be a numeric, you can find a reason somewhere in the column. There's probably a comma or a G or a KM or something to turn everything else into a character. Okay, so the next thing that we're going to talk about quick before a break here is indexing and subsetting vectors. So we have this whole list of animals, and let's see what it looks like because I forget. We have elephant, rat, and kangaroo. Suppose that we want to just extract whatever the second element of this vector is. We all can see that it's rat, so we could just use rat, but in a lot of cases, you actually want to extract a single element by its so-called index. And so we can use brackets to indicate where in this vector we're interested in pulling data from. So if we say animals and then brackets 2, we'll end up with rat. And we can also use indexing with a vector to extract multiple elements of the vector that we're talking about. So if I say animals with the index brackets and then give it a vector of 1 and 2, we should end up getting elephant and rat in return. But this this form of subsetting is very order oriented. So if instead I said animals and then a vector of 2, 1, we should get the opposite order of what we put in the first. See that we have rat and then elephant rather than elephant and rat. We can also use this form of subsetting to extract something multiple times. So this can be useful, but it can also really screw things up if you're not careful about it. So we can do multiple simultaneous subsets and say animals, and then our index brackets, and then a vector of 1, 1, 1, 1, 1, 3. And we should get a bunch of elephants over and over again before we finally see kangaroo. Sure enough. So R is actively looking at the first element of animals 1, 2, 3, 4, 5 times before it decides to look at the third element. We can also do what's called conditional subsetting. And this is where we use some of those logic functions we talked about last week, 2 weeks ago, last week, to subset based on a condition. So let's look at our weight in grams object. That has the numbers 10, 29, 14, and 12. We can subset based on the index, just like we did up above, and say weight in grams at the first element and get 10. But we could also subset based on true and false values in sort of a vector format. So once again, we'll use those brackets to indicate we're indexing, but then we'll feed it a vector of true, false, false, true. And what we should see is that we'll get, yes, we will access the first element of whatever weight in grams was. No, we're not going to access that second one. No, we're not going to go for the third one, but the fourth one we'll pick. And so sure enough, we see that we end up with a vector that has just the first and fourth elements of weight in grams. Are there any questions on that? Because that's kind of a tricky thing to wrap your head around.
When would you apply that? Like, when is that useful to use?
That's a great question, and it will become a little bit more obvious here in a moment. So just give me one moment before I answer that and see if there's any other questions. Okay. So to answer your question, Megan, what if we say weight in grams greater than 13? That would be testing if anything in weight in grams is greater than 13. And remember, weight in grams has 10, 29, 14, and 12. So the first and the fourth elements in this are not greater than 13, but the second and third are. And when we run that, we're asking it for each element of weight in grams is greater than 13. And if we are only interested in animals that are heavier than 13 grams, we can use the value that's returned by this logical test to subset our original vector by using the true-false elements of it. So let me show what that looks like. Weight in grams, and then our indexing indicator, and then we'll just put inside weight in grams greater than 13. And what this should do is ignore the first one that's less than 13, include the second and third elements, which are greater than 13, and then ignore the fourth one, which is also less than 13. And sure enough, what we see is we only return those two elements that are greater than 13. Does that make sense? Okay. let's see. Okay, we can also apply more than one condition. And to apply more than one condition, we need to use some symbology to indicate that we're actually interested in more than one condition. And the two big ones that you run into a lot are and, which is indicated by the ampersand, and also or, which is indicated by a vertical bar. And on a Mac, that is the shift plus the key above your return or enter button. I'm not sure where that lives on a PC keyboard. Does anybody see it on there?
It's in the same spot, like right above the enter key.
Okay. So once again, the that vertical bar indicates or, and the ampersand indicates and. So we could say we're interested in any animal that is heavier than 13 grams, but lighter than 20 grams. And if we wanted to do that, we would say weight in grams and then subset it based on weight in grams is greater than 13 and weight in grams is less than 20. And if this works right, we should end up with just a vector of length 1 composed of the number 14. Because we were looking at this weight in grams right here, and things that were above 13, so we're already limited to just the middle two, and less than 20, which removes that second one, and we're left with just the third element that is 14. We can also use or, so we could say weight in grams, and let's say anything that weighs more than 30 grams or anything that weighs less than 15 grams. Or weight in grams less than 15. And if you notice, there's nothing that weighs more than 30. So this first sort of operation ends up being nothing is true of, here, let's run this by itself to demonstrate. If we test what elements of our weight in grams are greater than 30, false, 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 false across the board, because nothing weighs more than 30 grams. But there are a few things that weigh less than 15 grams. So if we use this OR function, it's asking, where do we see trues at all here? And we saw a true for the first element, nothing in the second element, a true in the third element, and a true in the fourth element. So the first element being 10 was not greater than 30, but it was less than 15. And you can kind of go across the board there and think about it yourself. But what if we said weight in grams wherein the weight is greater than 30 or the weight is less than 1? Should we get any values from that? No, because there's no cases where either of those conditions hold true. And so here we get a numeric because our understanding is 0 because nothing satisfied that series of requirements that we gave it. Okay, we can also do this with character vectors. So just really quick, character subsetting. We can say animals, which contains elephant, rat, and kangaroo. And we can say, okay, which elements of this vector are equal to rat? So we can say animals and then our subsetting brackets and animals equals, because when we're testing a logical comparison with the equal sign, we need to have 2, and then rat, and we'll only get rat back. Or we could do the same thing and say animals equals rat or animals equals elephant, and we'll get both elephant and rat in return. If you check out the course materials online, there's also a %in% function, which is kind of complicated and I rarely use it. You may find yourself in a case where you do want to use it, so I'm just going to show it here quick. But it's not something that you'll always, it's kind of uncommon, I feel like. So if we say we have a series of animals that we're interested in, and we want to see if our animals vector contains any of them, we could say squirrels and bumblebees, I'm not sure if that's one word, and kangaroo. And this will test if anything in animals can be found in this vector on the right side. And so the first element of animals, which is elephant, is not in this vector. The second, which is rat, is not in this vector, but kangaroo does live in that vector. So this percent in percent function is another way of subsetting vectors based on sort of a list of things that you might be interested in. So really quick here before, oh, go ahead.
If I can hop in quick, one thing I would note about the percent in percent is just know that, you know, right now we're working with, you can read every entry in the squirrels, bumblebees, kangaroo vector. But if you come to a point where you're working with huge vectors that are far too big for you to read, to scan by eye, and you have two different vectors containing values, this can very quickly tell you, are any of them found over here? Like maybe you have a list or a vector of sites that you know have something to do with them, like sites where it rained. You have some new data you read in, and you want to say, are any of these sites in my vector of sites where I know it rained and something happened? You can very quickly access it that way. So a lot of these things seem kind of trivial at this point, but this is a foundation that a lot of stuff builds off of, and these things may become more useful later on.
Yeah, something that I find myself using this percent in percent thing for a lot is with mapping, because if I want to map the United States, Canada, and Greenland, but I have a data set that has all the countries in the world, rather than typing out countries wherein countries equals United States or countries equals Greenland or countries equals Canada is like a really big pain in the butt. But if I can say countries wherein countries are in this list of stuff that I'm interested in, it's like kind of a shortcut to subsetting that is super useful once you have lots of stuff to look through. So the last thing we're going to do before the break is logical comparison, where we can ask R, 4 is 4 greater than 5? And we see true, but is 4 greater than 5? So take a minute and pop out RStudio and see if you can figure out why 4 is greater than 5. Play around with it until 3:08, and then we'll have a quick discussion. All right, I know I said 3:08, but that's actually a pretty long time, and some of you may have figured it out already. So does anybody have a guess for why 4 is greater than 5?
I'm guessing it's because it's alphabetical.
Yes. So if we ask, is 6 greater than 5? we should get a true there as well, because it comes later in the alphabet. And we could similarly ask, are bananas greater than apples? And I would disagree with this, but R thinks that bananas are greater. So you can do some weird greater than, less than logical comparisons with characters that maybe don't always make sense. I'm actually curious, if we ask, is true greater than false? Does anybody have a guess for what we would get with this?
It's not going to work because those are going to read as numerics.
So if they read as numerics, what should it return as?
Oh, so it's going to be true because 1 is greater than 0.
Nice. Cool. All right. So with that little brain teaser in the back of your head, let's take a, Liza is, okay, let's take a 10-minute break and reconvene here at 3:18.
I put everybody in breakout rooms, Christian?
Sure, yeah.
All right, are we all here? No.
Not that I was creeping, Christian, but I was sitting here and the squirrels also do that in our backyard. But what we do is we let one of our cats out and the cat chases the squirrel. Just but
That's
can't
very
climb a
quick
tree.
solution.
Yeah.
At one point, our neighbor Joanna was asking her husband for a super soaker. And just imagining her back there, like shotgun blasting a squirrel with water all afternoon.
Oof. Well, on that note, actually something I miss about being on campus are like the incredibly aggressive squirrels outside of Wixon. But so it goes.
I saw like a post on Facebook about some cat that hangs out near the physics department, and they call him Cheeto, I think.
Oh, yeah.
Posting pictures to tell people not to feed him because he was obese.
Yeah.
And it was like making the squirrels obese too, because they were eating all the food left over that he didn't eat.
Yeah. Cheeto will like go over to you and like meow and kind of like nose you and kind of like look like he's expecting food.
Yeah.
Buddha has a vendetta against the squirrels outside of Wixon. Every time I bring her out to pee, she decides they're her nemesis and she's going to chase them relentlessly.
They're like a squirrel gang. They kind of scare me. They like line up outside the door and like try to scare me off. So good for you. But all right, it's about 20 after. I'm gonna go ahead and make sure I'm sharing the right screen. Okay, our screen, yeah. All right. Okay, so Christian just sort of left us off learning a lot about different data types. And there is, if you have been following along on the website, one sort of more bit to this that talks about math using vectors, which we will circle back to at the end of the day if there's time, or maybe early next lecture because it's important, but the rest of this lesson is sort of a second cohesive unit, and I want to give that a little bit of attention because there's some issues that will inevitably come up when you're also dealing with your data. So the first thing that we're going to talk about is what do you do with missing data? So all of the vectors that Christian has put together so far at least have all numbers or all characters. But let's say that we have a new vector here because everything that I have is empty right now, where we have, oh, we don't want that. We have a series of heights of, say, plants, but we have some NAs in there, right? So you'll notice that when I typed this in, I just typed in NA as it is. I didn't put it in quotation marks. And also that it is sort of this softer color blue, which is kind of a good sign. It's actually the same color blue as true and false. So that's sort of one of the first signals that R will give you as to what kind of data type it is, and allows me to put it into this heights vector You can see it over in my environment there, but we can also inspect it where it looks like it has, what is it, 6 elements. And it tells me over here it's a number. We can check that really by checking out the class of heights. And great, it tells me that this is actually a numeric vector, despite the fact that it has an NA, which we could conceive of as a character, but luckily R does not do that. It knows how to read NA without quotations as it's fed into a data set. So that's really useful information for us. R can read NA. But when we want to perform some basic functions on our list of heights, say, let's say we want to get the mean of our heights vector, we get back a mean down here we can see of NA. So not exactly the answer we would want. And this pattern persists pretty much any other function. Our max is also NA. So what's happening here? Basically, R doesn't really like to perform functions.
If you try to,
sorry.
Oh, I was just gonna say, if you can't like add and divide in NA because it's nothing. So if you're trying to do math to nothing, it's nothing.
Right. So it's reading this NA in
Right.
as an integer, but yeah, but it's not actually a numeric value. And we could inspect this, I think, by looking at type of, if we just did NA, it actually tells us that NA is a logical type, which is why it's the same color as true and false. But so even though it will read the whole vector as, luckily as numeric, it still can't quite do mathematical functions on it. So what we need to do is we need to be able to remove, NAs from like particular functions. We'll just leave it at remove that for now. And the main way of doing this, and a really useful cheat, is by using the code na.rm, which really just stands for NA remove. And we can do this within the functions of, say, mean. So we can run this again with heights, but we're going to add another argument into this function, and it is just going to be that na.rm. So we're saying, do you want to remove the NAs? And R is helping me, right? It's prompting me, it's telling me that this is an argument that I can put in the mean function. And it even tells me that NARM has to be a logical value indicating whether NA values should be stripped before the computation proceeds. So that's a really handy little tip. I didn't even have to ask the mean function for it. But so it wants a logical value, which is going to be true or false. And I'm going to tell it true. I want to remove the NAs from this vector of heights before computing the mean. And if I do that, then it does actually spit out a more sensible mean value, which is 8.4. A question that I sometimes have outside of these normal functions is sort of, can I use na.rm in this function? Is it an argument that it will take? And this is just a reminder that we can query what certain functions mean or how to use them by using the question mark in front of them. So I typed question mark mean, and in my help tab popped up a summary of what this function does, what arguments I can put into it or have to put into it. And it does tell me that you can use this na.rm argument. And by setting it as true, then we can get the answers that we want. So the same will be true for max or for anything else we want to do. And also as a note, for these logical types, true and T as a capital T are equivalent in R's mind. So it will still run if I write true out fully, if I just use a capital T or just use a capital F, and we will get our max value of 12 here. All right, what else? So that NARM is a really good way of removing NAs from a certain vector, but what if you want to sort of explore it and ask, where are these NAs and how many do I have, say, in this vector? So our next function that's really useful is this is.na, and it's more asking, is there an NA here? That's a pretty logical question. It's a yes or no question. So we can see if we ask R, is there an NA or are there NAs in heights? It will output a logical vector of a series of falses, but one true in the 5th spot where the NA is. The opposite of that, another kind of handy thing that we can learn is that an exclamation point represents really no or not, or the opposite of. So we can use this in a lot of different contexts, but this is one of them where you can put an exclamation point and say, is there no NAs? You kind of have to use your like logical brain sometimes when you're using the exclamation point. But I want to know where the NAs are not in heights. And what we would expect from this, given that we just saw this logical vector for is NA, we would expect and see the inverse of that. So any true now represents a numeric value that is not an NA, and we only see a false where our NA is in this vector. All right, now we talked a little bit about conditional subsetting because it's great to be able to know where our NAs are, but most often what you're really going to be wanting to do is kind of finding the data where no NAs exist, because that, you know, say in a model, it will often drop your NAs or drop the entire row where the NA is. And so it's really good to be able to extract the data and exclude the NAs from that. So this is where we can sort of combine these new functions that we've learned with the conditional subsetting that Christian talked about. So we can use subsetting to identify, I'll say non-NA values. All right, so remember when we're subsetting, we're going to start with the name of the vector, and then within brackets, we're going to put what the condition is that we want to meet in order to extract these certain true values. So in this case, if I want the non-NA values, this is sort of like the logic game, I would do an exclamation point because I do not want the things that are NAs within heights. So this is a reminder that within these brackets, trying to subset out the things that are not NAs. And what we get is now a vector of 5. These are all integers, and our NA has been dropped. So now this is something that could be useful if you want to see all the bits of your data that have no NAs. You can, of course, do this the other way around. It's not really as interesting, but if you wanted to know, well, where or can I look at just all my NAs? Of course you can. It will show you just one NA, and you really should expect that your NA would present as an NA, but this can be really useful for figuring out, you know, potentially if there's systematic missing data in any of your data sets. These like really basic functions I use a lot for inspecting data. And there is also a function that does more or less the same thing. It is maybe a little bit more intuitive. It's called complete cases. So instead of using the is NA function, we can subset just the complete cases, and that's the function in itself. So we can type this out. It can autofill it for me. And I would like the complete cases of heights to be subsetted out. And we see the same output here as we did in the not NAs. So these are more or less asking R to do the same thing. So how about up next? This is sort of a brief look at NA data, and there's a lot of different ways of exploring it. But if we flip over to our website, we have another challenge. Let's see. Aha, okay. If we're open on our website, there's a challenge here, and you can go ahead and open this up on your own website. I would recommend copying and pasting. You are able to copy and paste this, whatever sort of code is pasted into here, so that you make sure you get all of these values the same. And let's take, you know, like Christian said, paste this in, start thinking about it on your own for a minute or two, and then we'll send you into breakout rooms to chat about the different tasks that you're given here, which is create a new vector with the NAs removed, find the median of the heights vector, and then try to do a conditional subset to figure out which of these heights are taller than 67 inches. So you can take a second to do that, and Nick will send you into breakout rooms in a minute. suddenly unable to see how many people are back. Are we all back?
There's only 15 of us right now.
Okay. No.
I think you're good now, Liza.
Okay. All right, so our challenge, we're all working with the same string of heights. Who wants, and our sort of 3 goals were getting the vector, the median, and greater than. So people just want to shout out, how did you get the vector without any NAs?
I so I read in the data and then I made a new vector heights 2 and then just said heights, then the index complete cases heights, and then that made a new vector I could work with.
All right, let's check it out. Looks good. Heights 2 now. Oh, that was wrong. Heights 2 now compared to heights has 2 fewer items, which are our loss of 2 NAs. So that looks good. Then what about getting the median?
Median parentheses heights 2.
Yeah, I mean, now we have it as its own object. So yeah, so there are 2 kind of, I mean, I guess first point is that this could have been done, you know, also in a different way, like I demonstrated using the inverse of is NA, but kind of you'll find that there are always more than one way to do things in R. But now we have our complete cases object, which then allows us to run our function quite easily without even having to add that extra argument. We could, of course, have put all of this, say, into median. So there's lots of different ways. The median of heights 2, and we get 64. And what about to figure out how many or what are the heights that are greater than 67? What code did someone try?
I did mine a little differently, and I used heights and then subset it with the exclamation point is.na heights, and then the ampersand and heights greater than 67.
Okay, so you did heights, you then indexed and did is.na heights. Am I remembering this right now? And then an ampersand.
Yep.
Of heights greater than 67, you said? Did it look like this, or am I off?
Yep, that's right.
All right, yeah. So Brandy put this all sort of into one where she isolated. So this first argument, this first bit in the index is that she subsetted the heights that are not NAs, and of those, which ones are greater than 67. So all in relation to our main heights vector. So this is sort of combining, in a way, step 1 and 3. So that's a really awesome way to do it. And you can see that we have 6 heights that are all greater than 67. What about any other approaches to this?
Someone has a good one in the chat.
Yeah, in the chat.
Okay, I got it. Maybe I don't.
I can describe that one if that would be helpful. Yeah. So someone.
I got it.
Yeah.
Okay, yeah. So, well, I'm starting to read Logan's, which is that. So she started with doing kind of the original. So now that we have our vector without any NAs, which is heights 2, subsetting, doing a conditional subset where what of heights 2 is greater than 67. Then if you do just this subset, you get the same list that Brandy got before, but then also added the length function, which we learned earlier, I think, in front of it, so that you can get a count of how many of these heights are greater than 67. Yeah, so that's also like an added bonus. And like I said, this is kind of a quick snapshot of 1 or 2 ways to do each of these. And you can get creative. Some people try to compact it as much as possible, but it's also a good lesson in that there are lots of right ways to do this, and you'll find your own groove in that for sure. Cool. Then
can I interrupt you, Liza? There's one other good one in the chat that hasn't come up yet. That's using the sum function. So when we have trues and falses, they get coerced into 1s and 0s. So you can ask what the sum of values greater than 67 is, and it's not the sum of those values, it's the sum of how many values there are, to give a quick.
Yeah, so and all of these, sometimes if you're not sure what's happening inside one function, or especially inside like a few nested functions, it's good, you can highlight the little bit of code that you want to run and ask like, okay, what is this telling me? Just this part before the sum. And when I ask it, if I ask R whether or not heights2 is greater than 67, again, this was a logical question, and I get this string of false, true, false, false, etc. And so what sum is then doing, so I think, Christian, you said that it's not adding up the values, but it's adding up the values of the 0 or the 1, if we remember that true and false are logical, representing 1 and 0. So it's adding up the numbers of trues that it sees. So using, and you'll, as this is sort of one of the lessons of why these data types are important, because right now length and sum might be acting the same because we're dealing with a logical vector as far as what it is that, or rather what we're dealing with here is a numeric vector and it's telling me the length. But if I asked, say, for the sum of this numeric vector, we would not get the answer 6, right? We would, because when we're just asking this logical question, we get a string of trues and falses. But when we're subsetting this logical question, we get the actual numeric values. And so by asking the sum of numeric values, we get something different than maybe what we anticipated. So I'm just going to say don't do this, but really make sure you know your data types and what type of data you are putting into a function, I suppose, which is really just a cautionary tale of why these things, these basics, even though they seem really abstract to start, become the foundation of almost every problem you'll have in R, but can also then lead you to really clever solutions when you start realizing what's being represented in R. Yeah, so that was a great example. Cool. So I'm going to reserve the last 5 minutes to go over homework, which means we're going to spend the next 10 minutes just talking about one more data type for the day, which is going to be factors. And again, on the website, you'll see that there'll be some explanations of all different types of data structures that we will become more familiar with in the future weeks. There's sort of short summaries about what are lists, what are data tables and arrays and matrices, and all of those. Familiarizing yourselves with these words and knowing that the definitions are on the website is super helpful, but I'm not going to take the time just to read through them because I want to talk about this kind of one more data structure called a factor that does, I think, come up a lot in the work that I do. And we were chatting on the break about how finicky they can be. So we're going to spend some time with them. So factors are really like how we can think about categorical data. And so, for example, a really basic factor, or at least a categorical bit of data that you might often work with, is going to be just something like sex. So let's say across observations, you have a female, and a male. So off the bat, if you just type in a character string like Christian showed earlier, what you have is just that. It's a string of characters. But factors are what really are a lot easier to work with, or at least can be useful to work with when plotting and for certain model types. And so just like Christian talked about coercion before, what you can actually do is you can more or less demand or coerce R into being a factor. So I could have rewritten out that whole concatenated string again, or I could just tell R that I want sex to be a factor. And you can see that it's changed in my environment, and its class is now a factor. But what's really interesting about factors and what makes them both really useful and really tricky is that if I dig a little deeper into this type of, so class gives us kind of the general class of it as a factor, and type of will tell us something a little more specific, which is that somehow sex is both a factor and it's considered an integer, because R is looking at this factor and giving it these ordered numbers to represent the character values that are sort of layered on top, which we sort of logically do this when we put together data. So say you have a treatment that's like low, medium, and high, and maybe instead of writing that into every data cell, you actually wrote 1, 2, 3, because in your mind, those are factors. And even though you're representing them numerically, you want that you know it's written somewhere that those are represented as something categorical. R can do this too, but it can also mess with you in this regard because it doesn't, it gets really stuck on order. And so being important that you know how R orders characters and how R orders factors requires some attention. But so let's explore this just a little more. I talked about this idea of levels. So I can inspect what my levels of this factor are by using just the levels argument. Level, you can also ask it n levels, which is just going to tell me the number of levels that I have, which right now is easy to read, but may not be in a much longer vector. But right now what we see is that the levels are represented as female and male. So we're kind of getting used to how R thinks about data, but why do you think they came up in that order?
Because alphabetically female, F comes before M.
Yes, so R will by default order your factors in alphabetical order. And so it doesn't care, for instance, that low, medium, and high, it makes intuitive sense to you. We will kind of make sense to us, I guess. It will order it as, what will that be? High, low, medium, right? So that's just sort of an example of why this is super important to pay attention. But what you'll want to do, and what you'll always want to do if you're working with factors, is check out its levels, and then we're going to talk a little bit about, how to reorder. There are a couple ways of doing this. Let's see, and what are they? So first of all, you could just order them from the start. So when I first assigned sex, back up here, when I assigned sex as a factor, you could be really specific instead, and you could say factor, you'll take your sex vector, and you are going to assign it. So again, R pops up for me, and it will tell me sort of all of the different arguments that I can make. I'll actually ask it first. And you can see that levels is actually an argument within the factors function that I can set. So I am going to tell R that I, in fact, want the levels, despite it wants to put them alphabetically. Let's say I want to put them male first for whatever reason. So now the levels of sex order are male and female. Just gonna let that sink in. Does anyone have any questions about what's happening here? No. Okay. You can also rename levels. This is generally, I guess maybe it's worth exploring. Levels is how you're exploring, and like how Christian showed you can use brackets to sort of explore different components of a vector. And let's say I want to see the first element in my levels of the object sex. It will tell me that it's female. I can do the same thing for male. Okay, And to rename them, you can reassign, kind of using our assignment arrow, to these specific levels. So I've already, remember, we identified that this is female. Let's say that I want to call it instead female in all caps for whatever reason. Now my levels are female, male, so it adopted one, not the other. I could change them both if I wanted without, so if I don't specify any particular element of the level to change, and I instead give it a list of new names, and what we should see are now my renamed levels in all caps and in the order that I have previously specified. Any questions on that? All right. Oh. No comment.
I feel like the challenge is kind of what you just did.
Okay. Yeah, and so this is something I would encourage you to check in on, and whenever we'll review this, it gets especially interesting when you have other columns or other vectors that are attached to these factors, and making sure you're renaming and moving things appropriately. So this is something we'll come back to, but this is a brief look at how to think about factors. And one just sort of last bit is kind of this revisiting converting data types. Christian talked a little bit about coercion, but coercion with factors is, just a little bit more tricky. So let's say, for example, we create a vector of years, but for one reason or another, we originally assign them as a factor. So we start with this vector of years as factors. And when we investigate it, we can see our years, and we see that these are actually our levels, and they have leveled themselves in numeric order according to year, which is really useful. But let's say I don't want these years to be factors. I want them to just be numbers. If I try to coerce these years into another data type, so you'll notice when I typed this that this as dot function gives you a very long list of potential functions, and it's exciting. You can coerce your data into a lot of different forms, but you do have to be careful. But so we've talked a lot about numeric data types, and so that's what it kind of makes sense. Years are numbers. I want my years to actually look like numbers. If I try, however, to coerce a factor into a number, even if they all look like years, they're all pretty straightforward, what we actually get is the underlying number, right? The integer that the factor is representing as our coerced value. So if you're not paying attention with your releveling or coercion of factors, there are bound to be a lot of headaches. And it can drive you a little crazy. So one final question is, if I wanted to get this, so coercing factors to numbers does not really work. If I did want to coerce years back into numbers, you would have to make multiple coercion arguments. I don't know how to call this. Which I'm going to pop this in here as my last line of code, and you guys can sort of chew on it over the next week. But what this would potentially look like is that I want to first assign my factor as a character. And when I do this, I still get my years, but they're now in quotation marks, but R is now not thinking of them as like layers and levels. And because it's now no longer thinking of it as layers or levels, I can nest this within an as numeric function. And I will then ultimately get my years as numbers.
I once spent like 6 hours chasing down this bug because there was a function that generated factors and I didn't know it. And I didn't take the time to check that the output of that function would be a factor. And it was the hundreds of lines of code, and I could not figure out why I was getting these weird results. And I found this and I nearly cried. I was like, I think it was also after I had been teaching this class. So I should have known better, but that just goes to show, got to check this basic stuff.
Yeah. And I think someone can correct me, but a common function that we'll use of read CSV automatically converts characters to factors. So if you use read.csv, which many of us do, you are very likely to have factors as part of your data, even if you don't realize it, right? Is that correct? Or is it not factors? Yeah, it is factors. So this is a bit dense to end on, but we can maybe pick up with a little challenge at the start of next week to chew on it, just to make sure this settled in. And 2 minutes left, not bad. We will assign partners again. So I know the timelines are a little off. We asked by this week for you to, by the next lesson in the following week to have completed your assignments. I know that leaves like less of a deadline of, well, when am I supposed to review my partner's work? But we're still going to ask you for each week, in the next couple of days, comment on your partner's code so we can get into the habit of it, and you can look at some of the files, look at how they're organizing their Git repository. It will show you that there are a lot of different or correct or multiple ways of getting at some of these same things. Maybe this week less so, but it will become more true in the future. And so for week 3, which is this week's homework, we are asking you to start by pulling. So we went over this a little bit at the beginning of class, but you'll get into the habit of opening up your project, pulling from your Git repository so that you make sure that everything you have is up to date. You are then going to create an R script, so those .r files, and call it your week 3 homework. And if you haven't already, you should store this in your scripts folder that you can make as we instructed last week. And most of these instructions are pretty straightforward. I'm happy to hang back and go over them if anyone felt like that would be helpful, or Christian and I, luckily they started to be utilized, have office hours on Thursday and Monday. But we're going to ask you to just play around a little bit with subsetting and manipulating vectors so you can get comfortable with all of the logic that sort of R has in store for you. So with that, we are wrapping up, but does anyone have any final questions, clarifying points? And Christine, thank you, has posted in the chat the post-class survey. They take a minute. We do use them. We tried really hard to give you a 10-minute break today based on that. So if that's your biggest takeaway from this week, let us know. And if anyone has any,
if I can just add one quick thing.
Yeah.
I know it's easy to glaze over during these lessons, especially if you've worked with R at all. It can really feel like, yeah, I get how this works. I get how this works. But I want to emphasize that this type of stuff is extremely hard to troubleshoot. This is stuff that it's hard to Google. It's hard to figure out what an error message means if you don't have a good understanding of like what's actually going on under the hood. A lot of the later stuff we do, you Google stuff, you'll figure out how to get it right. And there are a million different directions you can go, but really building this core foundation and understanding how R is working on stuff and approaching how R thinks about stuff under the hood is going to get you over the hump of those error messages that you just can't decipher, or the problems that seem way too core for you to figure out. So this stuff might not be the most exciting, but it's going to save you hours down the line.
Yeah. Agreed. So thanks for that, Michael. These are your error messages. We'll use all of these terms we talked about today. And if you're not super comfortable with them, it just sounds gibberish, and pasting it into Google doesn't super help. So All right, cool. Thanks for hanging in with us. Hang back if you want, but we will see you next week, and comment on your GitHub repositories if we feel so compelled.
Thank you.